Hey students, this is the screencast to go along with that practice sheet that I provided on the information for the first exam that covers modules 0 through 2. So hopefully you already printed out the document. It was a Google Doc, worked on the problems to the best of your ability, and now you're watching the screencast to check your work and or figure out things that you just weren't sure about. Please don't use this as your only preparation for the exam because this is not comprehensive in the least. I simply picked out questions that I know were difficult for you as you guys were working through the first 3 modules. So I'm going to get started. I'm going to go through here. As always, if you have a question that you need answered, please do not hesitate to email me, okay? And I'm trying to learn my new technology here also, so that's tricky. All right, so we're looking at this equation, and kind of erase that too. So it's x squared plus 7x plus 12. All right, the point on this is not do I care if you know how to solve a quadratic equation. That's not it, and I'm not going to be testing you on whether or not you can solve a quadratic equation. So if algebra just scared you, take a deep breath and relax, okay? So the point for this is that I want you to know the difference between a problem and an exercise, okay? So if this were an exercise, it means that you have a method for solving it that you know works, okay? In this case, solving a quadratic equation, you could use the quadratic formula. That's that x equals negative b plus or minus square root of b squared minus blah, 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 right? This equation is easier than that. So this is x squared plus 7x plus 12 equals 0. And I could use a quadratic formula to get the answers, but in this case, factoring, hopefully this at least looks familiar to you, is the faster way. So I put x, and I put a plus 3 and a plus 4. And if you FOILed this, remember that word FOIL, if you FOILed it, you'd get back to this x squared plus 7x plus 12 equals 0. All right? If it's an exercise, you're going to keep going here, and you're going to say, hey, x plus 3 equals 0, or x plus 4 equals 0. And you're going to solve those equations, and you're going to get negative 3 and negative 4. All right, so if it's an exercise, you know how to do it. You don't have to figure out a method. You just get the answer. Okay? All right, next up, and for some of you maybe it actually is a problem. If it's a problem for you, how would you go about finding the values of x that make the equation true? Because that's what it means to solve an equation. Find the values of x that are going to make the equation true. I would say you'd come up with a strategy, and in this case, I might as well go back to that strategy that you can use when you can't think of anything else, which is guess and test, right? So you just say, hey, what if x is 1? Does that work? So you do 1 squared plus 7 times 1 plus 12, which is 1, plus 7 plus 12, which is 20, and no, because I need it to be equal to 0. All right, that didn't work. And then you would finish up by saying, keep guessing, right? Until you find the answer. And my guess is most people who used guess and test would only find one of the answers because they wouldn't know that there were 2. All right. So question number 2 says, hey, assume that you are going to solve this equation using guess and test. What would it look like if you were to use random guess and test? Well, it would look like, hey, what if x equals 1? Dot, dot, dot. That didn't work. I don't know, let's try x equals 3. So you plug in 3. hopefully at this point, you're getting a clue. I'm not even close, right? This is 9 plus 21 plus 12. That's 42. I'm really out of the ballpark, okay? But that's random guess and test. All right, systematic guess and test. Let me see. Yeah, I was going to see if I could put a space in there. Somehow when I copied it into Word, it's leaving me less space. But anyway. All right, what would it look like if you were to use Systematic would mean I'd really do a good job keeping track. I just found a typo. I'll fix it on Canvas, but you'll see it when you get here. So what I meant was inferential, okay? Inferential means you know something mathematically that make your guesses good guesses, okay? I'm going to give myself some space down here. If I look at this, think to yourself, what kind of number is x squared going to be? Right? Anytime you square a number, you're going to get a positive answer, right? And when I add 12 to that positive number, it's going to be more positive, right? If I need to get back to 0 again, that means I'm going to need x to be negative. Because I want 7x, when I multiply by 7, to be negative, right? The x squared is positive. The 12 is positive. So I've got a good chunk of a positive number. The only way to get a good chunk of a positive number to 0 is to have that same good chunk of a negative number. So that is an inference I can make here. And that inference is, hey, x has to be negative, okay? So that is inferential guess and check. It means I am using some mathematical knowledge to make my guessing better than just random. All right, question number 3, prove the following conjecture false. Okay, every time I give this exam, and I bet I will this time, I hope not, I give a question like this, prove a conjecture false. And people go crazy trying to write formal proofs, you know, with let n equal a natural number, or they try to, you know, make some kind of concrete proof, when all you have to do is say, product of 2 odd numbers, 15. Well, that's not even. So right there, I've just proven the following conjecture false. And I'm done. That's it. I move on to the next question. Okay? That's all you have to do. So to prove a conjecture false, you need one counter example. And that's it. Okay? So make that question short on the exam. All right. Next one, prove the following conjecture using a formal proof. Okay, so here's where we start. Same way every time. The mouse is just not cooperating. All right, so I start, let n equal a natural number. All right, remember, if natural numbers could be positive, or could be even or could be odd. All right, so I have to make sure I'm dealing with just odd numbers. And as you saw, hopefully, looking at the other screencasts during the proofs, 2n plus 1 is a way to ensure that I have an odd number. Because if I take a number and I multiply it by 2, I always get an even number. And if you add 1 to an even number, it's always odd. All right, if I need consecutive odd numbers, they look like this. Because if I'm at an odd number, say I'm at 5, the next one is 7. That's a jump of 2. So I have to jump from 1 to 3. And then I have to jump again 2 more. So a jump from 3 to 5 is 2 more, okay, to get to 9. All right, I need to find the sum. 2n plus 1 plus 2n plus 3 plus 2n plus 5. All right, let's put this together and see what it looks like. 2n plus 2n plus 2n, that is 6n. And I've got 5, 6, 7, 8, 9. Okay, so I'm going to factor this, and it's looking like I can take a 3 out. And if I take a 3 out, I'm going to be left with 2n plus 3. Okay? And now I need to say, hey, I know that this is an odd number. All right, inside here, it's going to be a number. All right, n can be 1, 2, 3, 4, 5, right? So this is a number, and I'm going to multiply it by 3. So in your head, think about this. Let's see, 3 times 1 is 3. 3 times... Sorry, I needed to pause there and I didn't. If I look at 2n plus 3, that is an odd number, okay? And if I have an odd number and I multiply it by 3, it's going to stay odd. So I would write a note, odd number, and then I'd say multiply by 3 stays odd. All right, and that's it. All right, next one, conjecture using a concrete proof. Okay, so I haven't done this yet, so this ought to be interesting, doing it on the fly. All right, I need 3 consecutive odd numbers. So I'm going to use 5, 7, 9. Remember, you start with a numeric example and go from there. All right, so I'm going to do 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, here's how I'm going to do this one. What I have to do is prove that when I bring down the numbers into my addition set, that I know every single time that it's going to be an odd number. All right, and I can do that. I'm thinking this way. I'm going to pull down pairs, okay? I'm out of pairs in the first circle. I'm out of pairs in the second here in a second. All right, go with it, right? All right, pretend I move all of these down here, okay? So that is 1, 2, 3, 4, 5, 6, 7, 8. All right, and then go back here and kind of take a look at, what do I have left? And what I have left is this guy, and this guy. And that's always going to happen. I've got odd numbers here, right? So I'm going to pull down the pairs. I don't know how many pairs, but I'm going to pull down the pairs, and then I'm always going to have 1 left. Okay? So there's always going to be 1 left in each circle. 2 of them are going to come down and make another pair. So right now I've got an even number because everything's paired up. But then I got this guy, and he also has to come to the circle. So he makes it odd. Okay? So that is my concrete proof. And it looks like I am going on to a second screencast, so I'll pause this one.